So joint central moment. So joint central moment is nothing but the expected value of the function x minus x bar power n, y minus y bar power k is called joint central moment. So we denote it as mu nk. Mu nk is what? Expected value of x minus x bar power n, y minus y bar power k. The formula for this is integral minus infinity to plus infinity. Integral minus infinity to plus infinity. What is the function here? We have x minus x bar power n, y minus y bar power k, fxy of x comma y dx dy. Okay. So here n and k are the positive integers. This n plus k, the n plus k is called the order of the central moment. Now we'll discuss what is zeroth central moment. How do we find out zeroth central moment? So we have discussed that n plus k is equal to 0. Then we call it as zeroth central moment. So we'll get 0 if both n and k both are 0, then only we get 0, no? So here, what is mu 0 0? Mu 0 0 is nothing but expected value of x minus x bar power 0, y minus y bar power 0. Okay. So we know that x minus x bar power 0 is 1, y minus y bar power 0 is also 1. So we get expected value of 1. Okay. So from the properties of expectation, we know that expected value of a constant is equal to the same constant. So the expected value of 1 will be equal to 1 only. Okay. So what is zeroth central moment here will be equal to 1. Zeroth central moment will be equal to 1. Now we'll discuss what is first order central moment. To find out first order central moment, we have discussed that n plus k value will be equal to 1. So what are the different cases where we get n plus k is equal to 1, where n is equal to 1 and whereas k is equal to 0. That gives you value 1, or k n is equal to 0 and k is equal to 1. It is also gives us the value 1. Okay. Only in this case we get the first order central moment. Okay. Now in this case, what is that? N is 1, k value is 0. If n is 1, what is that? We get expected value of x minus x bar power 1, y minus y bar power 0. Okay, since y minus y bar power 0 is 1, so what we get here? We get expected value of x minus x bar only. Okay, so how do we write this? So this can be written as expected value of x minus expected value of x bar. Expected value of x minus expected value of x bar. So you know that expected value of x bar is constant, no? X bar is what? X bar is the mean. Okay, it is the mean value. Since x bar is constant, okay, expected value of a constant is equal to the same constant x bar. And we know that expected value of x will also gives us the mean, that is x bar. Okay, so that x bar minus x bar is equal to 0. And similarly, mu 0 1. Mu 0 1 can be written as expected value of x minus x bar power 0, y minus y bar power 1. Okay, so that we will be having expected value of x minus x bar only. So this can be written as expected value of y minus expected value of y bar. So expected value of y is nothing but y bar minus expected value of y bar. Y bar is constant, no? Since the expected value of a constant is equal to constant only. So we get y bar here. So what is the value here? It is equal to 0. Okay. So from this what we know, the first order central moment will be 0. That is mu 1 0 and mu 0 1. Both are 0 only. Then we discuss what is second order central moment. Mu 2 0. Mu 2 0 can be written as expected value of x minus x bar square, y minus y bar power 0. Okay. So since y minus y bar power 0 is 1, what we get? We get expected value of x minus x bar square only. So it is nothing but the variance of x, sigma x square. What is sigma x square? Sigma x square is nothing but variance of x. Mu 0 2. Mu 0 2 can be written as expected value of x minus x bar power 0, y minus y bar square. Yes or no? So what we get? We get expected value of y minus y bar square. So this value, this is nothing but what? It is the variance of y. So it is sigma y square. It is the variance of y. Then mu 1 1. See here, when we say that it is second order, so we say that it is second order when n plus k value is equal to 2, then we say that second order. What are the different cases where we get n plus k is equal to 2? So here we have three cases, that is n is equal to 2 and k is equal to 0, then we get r is equal to 2, or n is equal to 0 and k is equal to 2, or n is equal to 1, k is equal to 1. In this case also we will get r is equal to 2. So these are the three cases where we get r is equal to 2. So that is why, so we are taking the third case also, that is mu 1 1. Here also the order is 2. So in this case, it is given as expected value of x minus x bar into y minus y bar. Okay. So what is this? This is nothing but sigma xy. So it is not sigma x square or sigma y square. Okay. So it is sigma xy. So what is the formula for mu 1 1? It is given as integral minus infinity to plus infinity, integral minus infinity to plus infinity. What is the function here? X minus x bar into y minus y bar fxy of x comma y dx dy. So this is the formula to find out mu 1 1. Okay. So now we discuss what is covariance. The covariance is nothing but the second order joint central moment mu 1 1. So just now we have discussed no mu 1 1. Mu 1 1 is what? Expected value of x minus x bar y minus y bar. It is also written as mu xy, sigma xy. This can also be written as sigma xy. So this is called the covariance. Okay. How do we denote? We denote it as cxy. Cxy is nothing but sigma xy. It is nothing but mu 1 1. It is equal to expected value of x minus x bar y minus y bar. Okay. So the formula just now we have discussed, the formula is integral minus infinity to plus infinity, integral minus infinity to plus infinity, x minus x bar into y minus y bar fxy of x comma y dx dy. This is the formula to find out cxy. What is cxy is called covariance. Okay. And for discrete random variables x and y, the cxy can be written as summation with respect to n, summation with respect to k. See here, xn minus x bar n, yk minus y bar k into pxn yn. Okay. For discrete case, we will be having probability mass function, whereas for continuous case, we will be having probability density function. Okay. So what is Cxy is summation with respect to n, summation with respect to k, xn minus xn bar, yk minus yk bar, p of xn comma yk.